Hey guys, welcome back. This is our third part from transformations over rotations. This is one of the assignments that we'll be doing along with dilations in person. So if you are still meeting in person, then you might want to wait till we do this one in person. So there are three rotations or axes of rotations for aircraft. We have the roll axis, which is what causes the aircraft to turn. That is actually controlled by the ailerons. So if you guys like aircraft, you'll like this stuff. So the ailerons, not the flaps, but the ones on the far end, have more torque, and so they actually turn the aircraft. And usually I create a paper airplane and I like twist the flaps or the ailerons on it and then make it twist and all kinds of cool stuff. Anyway, we also have the pitch axis, which is controlled by the horizontal stabilizers. If those move up or down, that's going to cause the aircraft to pitch, which will change the amount of lift that the aircraft generates without having to change the flaps, which is kind of cool. Nice little trick. And then the other one we have is the yaw axis, which is another way of turning the aircraft. That's done with the vertical stabilizer. But typically they turn the aircraft by using the ailerons, but they can do either one. Kind of cool. All right, so we're not doing anything that confusing. We're just doing stuff that's going to be based on the Cartesian plane. So, but it's kind of cool. Here's another example of a rotation. So for every rotation, we have a center of the rotation, which is our pivot, in other words. And then we have an angle of the rotation. The angle of rotation is how far we're rotating. So like if you rotate 360 degrees, clearly you do 360 degrees. Then the next thing that we have here is we have our A and our A prime. So the blue and the red triangle. Which one is the pre-image? So the pre-image is the one before the rotation, and then the image of the translation is the one that's the after, right? So that's going to be the image of the rotation. So how do we know the difference? Are we going from the blue to the red or from the red to the blue? Well, we know from this prime or tick mark here, that tells us that this is A prime, which is the image of the transformation. So this is the after, and the before would be the pre-image, the one without the tick mark or the prime on it. So we're going from the blue to the red. So the next question is our angle of rotation. Is it clockwise, which is in the direction of the clock, so 12 to 1 to 2 to 3, or is it counterclockwise, which goes against time, going backwards, right? So if we're going from A to A prime, that's going to be 120 degrees counterclockwise. And in case you're curious, we can also do this from the other direction, measuring it clockwise, and it would just simply be 360 minus that, which would be a 240 degree rotation clockwise, or 120 counterclockwise, which is kind of cool. All right, you also see pivot in basketball. So your pivot foot's going to be kind of your point of center of rotation, I guess is what they're calling it. Then your swinging foot is going to be what's actually going to be rotating it. Then however far you rotate it, about your pivot foot is going to be your rotation, so the image. So wherever you start out, that's your pre-image, and then after you do your pivot, that would be the image of the rotation. Now we're going to do a rotation from the Cartesian plane. So here we have the point A, which is 5, 3. We're going to rotate it 90 degrees clockwise, and then we're going to discover a general rule for this as well. So we're going to take this point up here, which is at 5 and 3, and we're going to rotate it down here because it's going to go to the fourth quadrant when we rotate it 9 degrees clockwise. So what we're going to do is draw an L and along the axes, and then rotate the L 90 degrees clockwise. It just makes it a little bit easier. So what I did is I drew an L going 5 along the axes, then 3 going into the quadrant 3, and I'm going to take that and I'm going to rotate it, rotate this blue L 90 degrees clockwise. So this is 90 degrees here, it's a right angle, and I'm rotating that clockwise. All right, so I took my L that goes along the axis 5 and then into the quadrant 3, and rotate it down the axis 5 and into the quadrant 3. So this point here is going to be our new location, or the image of the rotation, 9-degree rotation, which is going to be at the point 3 and negative 5. So 5, 3 turns into 3, negative 5. So you might notice the pattern here. What we're actually doing is we're switching the order of the x and the y. So 5 and 3 is now 3 and 5. And then we make the second one negative, and that's our rule. So in order to rotate any point 90 degrees clockwise, we switch the order of the x and the y, and we make the second one opposite. So it's y, negative x. Started out x and y, now it's going to be y and negative x. So if we apply the same rule to C, which is at 2 and 1, now it's going to become, so 2 and 1 turns into 1 and negative 2. So 1 and negative 2 would be this point right here. And sure enough, it is. And in case we wanted to do the L method as well, we are going to go in along the axes 2 and then up 1. Okay, so then we go down the axes 2 and into the quadrant 1. So, and then the other one going to B here, this point, is going along the axis 5 and then up 1. So down the axis 5 and into the quadrant 1, which would be this point right here. So there we have our B prime, our A prime, our B prime, and our C prime, and then we can connect all the dots. Because whenever we rotate the triangle, we're not just rotating the vertices, we actually rotate all the collinear points in between those endpoints of the vertices, and so all these points are all going to be rotated as well, because remember, the figure is actually made up of all the infinitely many points. So anyway, kind of cool. Just rotate the vertices using your rule or using the L. We'll do both of them on the homework, and then from there you can draw the rest of the points in between the vertices. All right, now we're going to do counterclockwise. So now it's going to be going against the clock, so it should go into the second quadrant here. So we're going to start out with a point A. So this is going to be so along the axis 5 and then up into the quadrant 3, and then we're going to rotate it 90 degrees counterclockwise, which is going to go 90 degrees this way, right? Okay, so that is 90 degrees counterclockwise. And then now we're going to go up 5 and then into the quadrant 3. So this should be the location of our A. I don't know if I put a point with that one. I guess I didn't. Which is going to be -3 and +5. So A is going to be -3, +5. So if you notice on this one, we're switching the direction, switching the order of the X and the Y again, just like we did for clockwise. But now we're making the first term negative or opposite. So just like counterclockwise, we switch them, and instead of making the second one, now we're making the first one. So no big deal. All right, so you can apply that. The rule is going to be X and Y turns into negative or opposite Y and then X. We could apply that rule to 5 and 1. So 5 and 1 is going to turn into -1, 5. So -1, 5, which would be this point right up here. So that's going to be our B prime. And then the point 2 and 1 is going to turn into -1 and 2. So -1 and 2, which is going to be that point right there. You can draw the L as well along the axis 2, up 1, and then we're going to go along the axis here after we rotate 90 degrees and into it, the quadrant 2. Same thing with B. We go along the axes 5 and then into the quadrant 1, along the axes 5 and into the quadrant 1, and then we connect all 3 of our dots, and that'll give us the image of the rotation of triangle ABC counterclockwise 90 degrees. It's a bit of a mouthful. Okay, so in review, if you forget the rules, because you're probably going to forget the rules, what you should do is just graph a point and then rotate the L on the test or something in order to remember how to do it. So let's take this point 4, 2. Let's rotate 90 degrees clockwise. So first, I'm going to go along the axis 4 and into the quadrant 2. And if I'm rotating it clockwise, it's going to go down, right? So I'm going to go down 4 along the axis 4 and then into the quadrant 2. So this point right here should be the image of A rotated 90 degrees clockwise. And that's going to be the point 2, -4. So if we notice, we're switching the order and the second one became opposite. So X and Y becomes Y and -X. Now if I want to rotate 90 degrees counterclockwise, it's going to go into the second quadrant here. So we're going to go take our L and we're going to move it up this axis 4 and then into the quadrant 2, which visually you can see it's pretty easy when you take the L and then you just rotate it, which gives us the A double prime because it's the second transformation that we did because A prime was already used down here. And now we notice that's going to be at the point -2, +4. So again, we switched the order. 4 and 2 is now 2 and 4, but we made the first one opposite. So that's going to be negative Y and X. So if you notice, both of them were switching the direction. Then on 90 degree clockwise, we make the second one opposite, and we make the first one opposite for counterclockwise. All right, so the only one that we haven't done yet is 180 degrees. Now, when we rotate something 180 degrees, it doesn't matter if you go clockwise or counterclockwise, you're going to end up in the exact same place. So we just say 180 degree rotation. So on this one, we started out with 90 degree clockwise, and if we go another 90 degrees clockwise, then our L is going to be rotated, so 4 and 2. So we're going to go 4 along the axes, and now we're going to go down 2 into the quadrant here. So this point here is going to be A double prime, which is at the point -4 and -2, which is basically the same order as the A, but now they're both opposite. So what we're doing is we're kind of applying the 90 degree clockwise twice. So we switched the order and made the second one opposite. Okay, so that's 2 and -4. Then we're going to switch the order again and make the second one opposite again, which is now going to be -4 and -2. Kind of seems a little confusing, but we could actually do the exact same thing if we went from the other direction. Unfortunately, that makes this kind of disgusting looking symbol, but you'll have to forgive me. So on that one, if we switch the order and the first one becomes opposite, and then we switch the order again, and then now the first one becomes opposite here, we end up with the exact same thing. So it doesn't matter if we go from the counterclockwise or the clockwise direction and we do it twice, we're going to end up with the exact same thing. So let me cover that up because it's kind of nasty. I don't want to look at it. There we go. Anyway, so whenever we do 180 degrees, it's actually the easiest one to remember because all we do is we make them both opposite. So we have x and y becomes opposite x and opposite y. So any point that you want to rotate 180 degrees, you just make the quadrants opposite. All right, so that was it for the lecture, about 13 minutes, not too bad. This is, again, one of the harder ones. That's why I chose to make this one that we do in class. But you can go back and reference the video. Even if you were in class, maybe you're watching the video now because you wanted to see it again. All right, so number one, we want to rotate it 90 degrees clockwise. So we're going to do the whole front page by drawing the L's, and then we'll use the rules on the back page so that you know how to do both. All right, so let's do the point C here. So I'm going to go 2 along the axis and then 1 up into the quadrant. Then if I rotate that clockwise 90 degrees, it's going to be now 2 along the axis and then 1 into the quadrant here. So this is going to be the point C prime, the image of the 90 degree clockwise rotation. And then for B, we're going to go 4 along the axis and then 1 up into the quadrant, 4 along the axis, 1 into the quadrant here. That's going to be our point B prime. And the same thing with A. I didn't draw that one because it's going to overlap so much, but basically 4 and 4. So we go up 4 and then in 4. And again, by the time you've plotted 2 points, you can probably figure out where the last point is going to go anyway. Then you can connect all the dots here. And this is going to be the image of the 90 degree clockwise rotation, our triangle ABC prime. So what we would say. Not bad. All right, 4, we're going to go counterclockwise this way this time. So we'll start out, I guess, with the point D. I can do that. So we're going to go 2 along the axes, 1 into the quadrant, rotate it 90 degrees counterclockwise, so it's going that way. So 2 along the axes, 1 into the quadrant. So this is going to be point D prime. Then we'll do the point F. So F is going to go 2 along the axes and then 4 into the quadrant. So we go 2 along the axes and then 4 into the quadrant here. Now notice I use different axes here. It doesn't actually matter. Just take whatever L you have and rotate it 90 degrees counterclockwise. So the green went to the green here, which was being rotated 90 degrees counterclockwise. Same thing with this red to this red here, went 90 degrees counterclockwise. CCW or whatever. Okay, anyway, so not a big deal. And then you can probably figure out where E is going to go. Well, E is going to go right there. So we have D prime, E prime, F prime. We can connect the dots and it'll give us our triangle. So this whole triangle here has been rotated 90 degrees counterclockwise. All right, what about 180 degrees clockwise? You know, I'm awfully tempted just to use our rule on this one because we know the rule. We're just going to make the points opposite, right? So if we have -4 and +4, that's going to become now +4 and -4, which is going to go right over here. And then -2, 1 is going to become +2, -1. And then -4, 1 is going to become now +4 and -1. So anyway, that's going to be the image of it rotated 180 degrees clockwise or counterclockwise. It actually doesn't matter when it's 180 degrees. It's going to end up in the exact same place. And if you need to draw the L's, you totally can. So we can do 4 and 1. So now it's going to go 4 the opposite direction and then down 1. You can do the same thing with the C prime here. I think I did that one. Nope, I must not have done it. Nope, I just did one of them because from there you can pretty well figure everything else out. All right, rotation 90 degrees clockwise. So we're on the back side. We're going to rediscover the rules here because we remember we switched the order, but which one do we make opposite, the first or the second coordinate or whatever? All right, so let's start out with 3 and 1, which is the point A, and we want to rotate 90 degrees clockwise. So we're going to draw our L. So along the axis 3 and up 1. Then if we do clockwise, we're going down. So 3 and 1 here, which is going to leave us at the point 1, -3. So what happened? We switched the order and the second one became opposite. So X and Y turns into Y and opposite X. All right, well now we automatically know what's going to be for counterclockwise. It's going to be the opposite Y and then the X. So the first one becomes negative and the second one's going to be our Y, right? Okay, but if we want to do it the right way, we can go counterclockwise up here and then into the quadrant 1, which gives us this point here, 1 and -3. So again, opposite Y and the X. So we switch the order and we make the first one opposite when it's counterclockwise. All right, so that was 9. Now that we've rediscovered those two rules for 9 and for 10, we can use those rules for the rest of the page. And please do. It actually makes things a lot easier if you don't have to draw the L every time. So let's look at number 13. We're going to take this triangle RST and we're going to rotate it 90 degrees counterclockwise. So if we remembered our rule for counterclockwise, and I'll go back here. So for counterclockwise, we switch the order and the first one becomes opposite. So we can rewrite that down here. And now I'm going to just apply that rule, kind of like how a computer would think of, just apply that algorithm to the rest of our 3 points to see what we get. So I'm going to switch the order and make the first one opposite. So -1, 2 is now going to become -2, -1. Okay, and then 3, 3 is going to become -3, +3. Then -3, 4 is going to become opposite of -3, which is going to become positive again. So +3 and 4. Okay, so notice the first one's all changed. The second one was just the first one, and it didn't change. So -2 and -1. So -2, -1, which is going to be this point here, R prime. And then -3 and +3 is going to be the point here, which is going to be our S prime. And the T prime is going to be 3 and +4, which is right up here. Then we can connect the dots, and that's going to give us the image of the rotation of triangle RST rotated 90 degrees counterclockwise. Now, if you tried to draw all the L's, it would still work, but it's going to get really, really busy because our triangles are in 3 different quadrants, the vertices are. So it's better sometimes just to know the rule or to be able to find the rule like we did on the last problem and then apply it to it, which will make things a little bit simpler. So if you have any questions, make sure that you asked. You can hit me up and remind if you want a quick response. Of course, I might be in class, so we'll see. Or you can always just make a private comment on Google Classroom. So I'll see you guys later. Have a good day.